Good morning, boys and girls, and welcome back. Today we are going to talk about the ratio test. And good news, I saved the best test for the last. The ratio test is a pretty good test, and it comes up a lot as far as like being directly asked about on the AP exam. And it's very versatile. It works for most of our series. So that's why, again, this is a good one. If you were going to focus on one test that you wanted to know, I would say you want to make it the ratio test. All right, so without further ado, here it is. Okay, so the ratio test states that a series is going to converge absolutely if you look at the limit as n goes to infinity of the next term, a to the n plus 1, over a to the n. If you look at the series to the n plus 1 over that series, if you look at that ratio as n goes to infinity, if it is less than 1, then the series is going to converge absolutely, right? A series diverges absolutely if the limit as n approaches infinity of a to the n plus 1 over a to the n is bigger than 1. And then the ratio test is inconclusive if this limit is equal to 1. All right? So that's these three things. I'm going to look at the limit as n goes to infinity of this ratio of the next term to the previous term. And if it is less than 1, it converges absolutely. Bigger than 1 diverges. If it equals 1, then it is inconclusive. So real easy to do. Okay, so first one here. We want to know if the series 3 to the n over n factorial is going to converge or diverge or what's happening here. So again, the first thing I always would do is run it through the nth term test for convergence. And in this case, we have talked about how factorials are going to grow faster than exponentials. Therefore, I know the limit as n goes to infinity is going to go to 0. So it passes that test. So now I'm ready to perform another test on it. And let's do the ratio test. All right, so let's start to set this up here. And actually, before we start setting it up, quick little side note. The other nice thing about the ratio test is that this works for all series. Positive term, negative term, there's no stipulations on this test. It works for all those series. So I can use it on an alternating, or I can use it on all of the tests. All right, so now to set this up. So we said this is going to be the limit as n approaches infinity of the ratio of our next term of n plus 1. So I'm going to write this 3 to the n plus 1 over n plus 1 factorial. Okay, so that would be the next term of the series, all over the previous term, or the a to the n, which is 3 to the n over n factorial. So I'm going to divide these two things and take the absolute value of it. Okay, now to simplify that giant complex fraction, you are going to skip this one, flip this one, and multiply. And so when I do that, I should get something that is like 3 to the n plus 1 times n factorial over 3 to the n times n plus 1 factorial. And now I want to simplify this. For the front part, that is not too bad, because when you have the same base, you just subtract exponents. So 3 to the n plus 1 minus n, 3 to the n plus 1 minus n, is just going to give me 3 to the first. So that's pretty nice, and my, the 3 n's, that part disappears. Now to simplify the n factorial part, and to do this, I'm going to do a quick factorial review off to the side here. If I wanted to simplify 7 factorial over 3 factorial, again, what you would do is you would start with the bigger number, the 7 factorial, and you would write it out till you hit the smaller one. So 7 factorial could be written as 7 times 6 times 5 times 4 times 3, then factorial over 3 factorial, and then now the factorials would, kill each other off. So this would just be 7 times 6 times 5 times 4. I'm going to do the same thing with my n's here, that same kind of idea. I want to start with the larger one, so n plus 1 is bigger than n, and so I'd have like n factorial on top, and then on the bottom I would have n plus 1 times n, and I got to take away 1 times n factorial. Oh, okay, so now I've got 2 n factorial, so they could kill each other off, and I'd be left with 1 over n plus 1. So a little work in simplifying there, a little algebra and everything. But when we finally do get it simplified, our ratio test simplifies to the limit as n approaches infinity over 3 over n plus 1. And now as that goes to infinity, this whole limit then. The bottom's going to go to infinity, and it's going to go to 0. And now, because when I did this, I got an answer that is less than 1, going back to our test over here, because we are less than 1, I know that this is going to converge absolutely. Okay? So, this converges. Okay, so this converges. All right. Let's try this again. Let's do another one. Oh, okay. Let's see here. If I were going to do this one, first thing, just looking at it, a couple things. If I do the nth term test, this would be a quick way to kick this one out. I'm going to continue on with this even though I know that this is going to never diverge. But if I, go to infinity, the limit as this goes to infinity, that's going to go, well, actually, that becomes infinity times infinity, which is indeterminate. So I'd have to do some L'Hopital's. I'd have to do some work on that one. I'm not sure if the nth term test would kick that out or not, but I'm going to guess the nth term test would kick that out. And it's going to tell us that this diverges. I'm also looking at the 3/2 to the n. That looks geometric in nature, right? And I know 3/2 would diverge as a geometric one, though, as well. So that kind of makes me, again, feeling this is going to be, divergent. However, I've got it times n, so who's to say that doesn't change things? So let's, I got a pretty good feeling this is going to be divergent, but let's work our way through it using the ratio test to see if it is. Okay, so when we set this up, again, it's got to be the next term, the n plus 1. So everywhere where I see an n, I'm going to plug in an n plus 1. So n plus 1 times 3/2 to the n plus 1 over my a sub n. So over the original sequence, n times 3/2 to the n. All right? And now I want to simplify that. So again, when I'm subtracting or when I'm dividing bases, when I'm dividing exponentials, I can subtract exponents. And so again, that would become 3/2. And I would end up with, the limit as n approaches infinity of n plus 1 times 3/2 to the first, all over n. Or, I probably could do it now, or I could, now go and multiply by 3/2 and end up with this. I don't know if you have to do this step right here, but, it does help me look at this and maybe think about it a little bit better. But if I take them as we go to infinity here, this back 3/2 is not going to matter very much. So this is really going to be like 3/2 n over n, and then the n's would cancel out, and so this would be like 3/2. And so because my limit is something greater than 1 now, I do know for sure that this is going to diverge. Okay, but the ratio test is good, especially on ones like this one. We kind of start getting a mixture of a couple different types of, series. This is a little geometric with, that linear guy there. So, is that going to converge or is it going to diverge? I mean, we did some other tests to kind of think about it to begin with, but we can always show it with the ratio test. All right, so our next one now, n cubed over 2 to the n. Again, if I ran this to the nth term test, exponentials grow faster than polynomials, so I know that it's going to go to 0, so it has the potential now of being convergent. So let's do the ratio test to see if it's going to be. So when I set up my ratio test, again, I get n plus 1 to the third over 2 to the n plus 1. All of that divided by n cubed over 2 to the n. And now I'm going to skip, flip, and multiply my complex fraction. You'll notice when I rewrite things, I do try to group the parts that go together to help me simplify those things. So now when I do this, n minus n plus 1, this is going to be 2 to the negative first, or again, just 1, 2 is going to be left on the bottom. So this would simplify to the limit as n approaches infinity of n plus 1 cubed over 2n cubed. Again, because we're going to infinity, that plus 1 ain't going to do a whole lot, so I'm really thinking n cubed over 2n cubed, and then so this would simplify to 1/2. All right? Because, again, I'm getting a value that is less than 1. Again, if you get a limit that is less than 1, we know that this is going to converge absolutely. All right, here we go. One more. Actually, 2 more. Okay, here we go, number 4. Negative 1 to the n times n plus 2 over n times n plus 1. Now, again, hopefully we are at the point where we're recognizing that this is an alternating series, because I've got this negative 1 to the n part right here. And so, again, I'm pretty sure I probably could use an alternating series test on this. But just to show you that that this will also work, again, it doesn't, that's the nice thing about the ratio test. It doesn't have to be just all positive terms. It will work on any, any series. All right, so let's go ahead and let's try it here. Okay, as we are setting up here, a few little detail things. First, because we're going to absolute value all of this, it's going to make everything positive. So I can leave off the -1 part, the alternating part. I could go ahead and get rid of that. All right, I don't need that in my setup for the ratio test. If I add 1 to n plus 2, I get n plus 3. If I add 1 to n, I get n plus 1. And if I add 1 to n plus 1, I get n plus 2. What you can do, too, as you're doing this, instead of writing it as one big fraction like we've been doing, if you feel comfortable enough, you can just come along and skip, flip, and multiply. And you could write it just like that, and that's okay. We could follow what we're doing there. That is the same thing. Okay, so if we simplify, the n plus 1s would kill each other off. And on top, I'm left with n times n plus 3. And if I multiply that, I get n squared plus 3n. On the bottom, I have n plus 2 times n plus 2, which if I multiply that out, I get n squared plus 4n plus 4. I multiplied out on the top and the bottom because that is a little bit nicer now is when I try to evaluate this limit as n goes to infinity. Again, I really don't care about this stuff in the back. I am going to think about just n squared over n squared, which equals 1. Now, because it equals 1, we said this now tells me that our test is inconclusive. We came, we saw, we tried, but in this case, the ratio test did not give me an answer. It kind of failed for me. Going back, we said we could do this with the alternating series test. So if I look at this alternating series, the limit as n goes to infinity of n plus 2 over n squared plus n, that is going to go to 0, so that passes. If I look at my terms, they are getting smaller, so this would converge because of the alternating series test. So it converges because of the alternating series test, but inconclusive due to the ratio test, which gives me a pretty good indication. I think this probably just converges conditionally, and not absolutely. And so that's why we're getting an inconclusive result on our ratio test. Okay, now last one. All right, this one's got all sorts of fun stuff here, right? We've got the -1 to the n minus 1, which isn't alternating. It's going to alternate us here, right? I've got 3 halves to the n, which is a geometric, which looks like that should diverge because, again, that's an r bigger than 1. But then I got over n squared, and so over n squared is a p-series thing going on. And that p-series would converge. So we have all different pieces of different stuff. Who knows what is really happening with this? This is a great time to go ahead and use the ratio test. Okay, so setting this up, we get them as n approaches infinity of the absolute value of 3 halves to the n plus 1 over n plus 1 squared. Get my whole next term plus 1 stuff. Times, and then I flipped it. Instead of just dividing by it, I skip, flipped, and multiplied. N squared over 3 halves n. And now I'm going to go ahead and rewrite this so that's going to be easier to simplify. So sometimes I just like to rearranging so they look a little bit nicer. And so I did that. I don't know if that step was 100% mandatory, but I kind of like it sometimes. And now I'm going to, again, subtract exponents on the 3 halves. And when I do that, I get 3 halves to the first power, or 3 halves n squared on top. And then on the bottom, I'm left with my n plus 1 squared. Again, I can't really simplify the n part back here. But now as I look at the limit as I go to infinity, this is more or less 3 halves n squared over n squared, because that 1 goes away, which this equals 3 halves. So again, because that is bigger than 0, I know that this diverges. All right, boys and girls, there's your quick little lesson on the ratio test. Again, if you got questions, hit me up. Otherwise, see you later. Have a nice day.